Welcome to our Semiconductor education program. I'm Vincent Chang. In this lecture video, I'm going to teach you the part 3 of differential amplifier, common mode half circuits, and the common mode rejection ratio. In the first part of the differential amplifier, I set a big picture. To give you a big picture, combining the differential part and also the common mode part. In part 2 of the differential amplifier, we focus purely on the differential mode analysis. In this video, we're going to focus solely on the common mode output, common mode part, common mode analysis. So you have to remember this. So what's this? The key message? Number 1, V1 and the V2 has no condition. It's arbitrary input. Arbitrary input. 2 arbitrary inputs. Number 2, the real output. The second point, the real output is the differential output plus the common mode output. It's going to create the real output. If we're going to do the pure common mode analysis, we have to set the differential part 0. Then if you set VD is 0, then what do you get? The left-hand side is VCM, the right-hand side is also VCM. RO represents the finite output resistance of the constant current source. Then, because of the circuit symmetry, the IQ is going to split. How about the resistance? The left-hand side bias current have IQ. The right-hand side is symmetry. How about the red resistance, the output resistance? Because when the two emitter direct couple, the parallel combination of these two resistance is going to become the RO on the left hand side. So 2 constraints. Number 1, due to circuit symmetry, the 2 resistance has to be the same. Focus on the right hand side. And then the second constraint is the parallel combination of these 2 has become original RO. So what's the answer? There is only one solution. It's double. Right? It's double. 2 RO. The 2 RO are the same. And the parallel combination of the 2 RO and the 2 RO becomes RO. This is the common mode half circuit. Common mode half circuit. Now, when we face the common mode half circuit, left hand side, right hand side is the same. Let's try to find out the common mode gain. What is the VC1 in terms of VCM and the rest of the component, including RC and the 2 RO? Let me repeat that. My question to you at this point is, what is VC1 in terms of VCM, RC, and RO, and the rest of the small signal parameter, AC parameter? Let's try to pause the 1 minute, use analysis by inspection to get the answer. The expression for VC1. Is 1 minute too short? Is 1 minute too short? Let's see if 1 minute is too short. In phase or out of phase? Out of phase. Right? So negative, put on the negative sign. And then what? See this? See this? Alpha is 0.99. It's negligible. What's on the top? The one on the top, put on the top. RC. Total collector resistance in the numerator. What's on the bottom? The one on the bottom put into the bottom. Grasp the emitter perspective. Grasp the emitter. Look into the emitter. Between base and the emitter, look into emitter. Inside is RE. And outside is 2RO. So total emitter resistance is RE plus 2RO. This is the answer. Is 1 minute too short or too long? VC1, VC2, the same. Because the half circuit is the same. Now here comes the common mode gain. It depends on how you define the output. If we define the differential output, let's say VC1 minus VC2 is the actual output, then in this case, the common mode gain will be 0 because the two output is the same. Single-ended output is the same. VC1 equals VC2. So subtract, cancel it out. 0 common mode gain. Let's pull what we learned from the previous video back into the left-hand side. Remember that differential mode have circuit. 2 key points. Number 1, grounded. Common emitter is grounded. Number 2, opposite sign. Half VD, negative, half VD. And differential gain, if output is taken differentially, then it's negative GNRC. It's been proven in the previous lecture video. Then, a good differential amplifier should make the differential ability as high as possible and suppress the common mode ability. So for this reason, we define so-called common mode rejection ratio. Common mode rejection ratio is the differential gain over the common mode gain. In this case, it's infinite. Why? Because the common mode gain is 0. But think about this. In the reality, common mode gain would not be 0, right? Because there is no perfect twin. There's no perfect twin. Even in the integrated circuit process, there's no perfect integrated. In the real world, there's no perfect match. There's always something that a little bit of variation cause a little bit match, cause a little bit mismatch on both sides, and then will cause non-zero common mode gain. Takeaway. There's only one takeaway, which is common mode half circuit. What's the key point to remember for the common mode half circuit? Number 1, the signal are the same. VCM, VCM. Number 2, double. 2RO. The takeaway for this, the learning objective is you have to remember this common mode half circuit. Know how to put down the common mode half circuit. And based on this, you can get the common mode ability or so-called common mode gain. This is the end of the lecture video. I hope you enjoyed the lesson, really learned the lesson. Thanks for watching.